Good morning, everyone. Welcome to our second online session of Foundations of Statistics using R. Hope everybody's doing well today. New York City, it's pretty chilly, 39 degrees and 8 a.m. So this is pretty early for many of us. But glad to see a pretty large group online. This is fantastic. It's also great to know and reconfirm the time codes that are the times that are working best for this group. So welcome. So let's dive in and see what we're going to cover today. So today's session, as the first one of the objectives is to ensure that you're successfully developing your skills and knowledge in R, and you're deepening those knowledge areas and skills. I want to give you an opportunity to practice, and we're going to do that through a few things. I'm going to do a few explanations of some questions that came up recently and of the topic for today, which we will get to in a moment. And then I want to obviously provide an opportunity for you to ask questions along the way. And if you have any other kind of like major things that you'd like to discuss, I'm here. So today's topic has to do with working with R packages, importing data, and writing R scripts. So that's what we're going to talk about today. We're going to work through exercise 3.1. If you kind of forget where that is, it's always available in the materials tab and also on our R Fundamentals website. So that's becomingvisual.com/R Fundamentals. And you just navigate to exercise 3.1. And if we have time, depending on the questions and other things, then we can start another exercise, 4.1. But I want to just pause and open it up to questions and just get a little bit of interaction to kind of make sure that you can hear me, that I'm not talking into the ether. So if you just can give me a yes, or if you have a question, feel free to pose it in the text chat. Thanks, Benson. Okay. And I don't know, thanks so much for the feedback. And please, it makes the class better if you provide feedback all the time. So if I ask you to provide a response or solution to even a simple problem, just like cut and paste it into the text chat. Even if you come in late doing it, you see 10 other people have done it, post yours as well. It just kind of adds to the diversity in terms of the solution types, and also just the dynamism of the class. So appreciate that. Something that came up recently that I thought was pretty interesting was, I don't know if you're following the discussion forum in this class, but there's a good amount of questions around, can't find R object. Anybody get that error? So you're writing your code and it's like R object, sidewalk not found, or R object, Winter Olympics not found. So Anne, you've got that before. Anyone else? So one of the things we're going to talk about today is importing our data and making sure that we recognize that when we import our data, whatever that data set is called, that's really thought of as an R object. It's an R object that is a data structure, obviously, right? We talked about data structures last time. So data structure is simply a way in which our data is presented in R and organized, columns and rows, nothing too difficult here. And it's an R object of a certain type, and it's usually going to be of type what? We have data that's that we import. My question to you is, what is that type? If I was going to say class and pass in my R object, which would be that data that I imported, what would the type be that would be returned? So people who are here at 8 a.m., I know this is a really exciting question for 8 a.m., but so I'm going to write something in the text chat. So if you did class data, what would it return? Right, it might return data frame. Thanks, Anne. Or it might return like something like Tibble, right? So that's just something that I want to make clear, and we'll explain what the differences between those two are. But just to kind of bring it back to where we started from our last session, that data can be of a certain type, and then we have data structures that can be of a certain type as well. And each of those vectors or columns in a particular data structure, like a data frame or a tibble, can have a type as well. And those types can be of type integer, of type character, the more familiar types. But then we have broader structures like data frames and tibbles, okay? And all these things are thought of as our objects. And objects are simply instances that we instantiate of let's say data, for example, that then we can manipulate with methods or functions, okay? And so the whole foundation of object-oriented programming you might have heard of stems from this idea. So we have some kind of, template or what we call like an interface for how to create, some type of data structure. And we use that to simply as a guide to, we import our data, and that becomes an object that's instantiated that then we can manipulate. Well, David, that's a good question. So what's the class before we change it to a data frame? It's when we import it, it's being imported as a data frame or as a tibble. So good question, David. So that's one clarification. So if you ever get that error like our object not found, it's probably your data. And it's probably because you might not have referenced your data correctly or imported it as part of your script. And we're going to get to bringing these concepts home in a little bit. So David asked, then why do we assign it to a data frame? So there's been an example where you might have had something that was a different data type, like a matrix, and then you've converted it to a data frame. Okay, but you're not assigning it to a data frame. You've what's called either cast it or it's been coerced. You're probably, actually I shouldn't have wrote cast like that. It's not a method. You've used a method that casts the variable. So you might have said as.data.frame. That might have been something. And that's not assigning it. That's a casting. So you're taking something that's different for whatever reason, was a different type, and you're making it a data frame. Okay. Let me know if there's more questions on that as we go through. I'm going to speak to importing data today. Another thing that came up is differences between a few different characters that we use in coding. So I'm going to write a few out. Double quotes, okay? Double quotes, that's right next to the return key. To the left of that, you have to press shift to get your double quotes, right? We use them all the time. So that's one character that we use. Anytime we use double quotes around, like, let's say a word, it's usually thought of as type character, okay? There are instances where we might use, single quotes as well. And then there's something called a backtick. That's the left of the number 1 sign, right below the tilde. Single quotes and backticks are different characters. So you might have been writing some R code in what we call inline R code, and you might have used the single quote instead of the backtick. Backtick is a little bit of unusual of a character that we don't use every day. And so I just want to emphasize that in most cases, we're either using double quotes or the backtick. We're rarely using single quotes, okay? So that's why that's something that's important. Also, if you are writing your code for whatever reason in Microsoft Word, you'll get quotes that are called smart quotes. These are not recognized by R, okay? Don't write your code in Microsoft Word. None of you have, but I've seen that that happen before. So just to know that that's another kind of error-saving thing. So what you're probably learning along the way over the past couple weeks is how to interpret some error messages and how to fix them. And in addition to developing new skills in learning R, for those of you who are new to learning it, or learning coding altogether. So please feel free as we go along to ask any questions. And if I can't get to them, then I will follow up in an email. At the end of every kind of online session, either the same day or the next day, I usually send out an email with the recording. So I hope that's helpful. But just know that on the R Fundamentals website, and I'm just going to go there real quick. That we're going to go over exercise 3.1 today. But right under this, in the navigation we're mousing over, there's something called a code walkthrough. Here is kind of like a hokey video of me, but a video of me kind of going through how to solve the exercise. So you also have that. So you have the solution. I mean, it's in video form, but this video is probably like a minute or something like that. So even though I give you the recordings of these online meetings, this is kind of a quick way if you just wanted to see the solution and kind of be walked through it a little bit. Okay. I also find it useful. You could even listen to it. You don't actually have to see it because I kind of describe what's going on. Let me know if what materials are helpful for you too. That's helpful for me to keep designing these to support your learning. Oh, thanks, Stephanie. Appreciate it. So it's interesting when you're a faculty these days. You're on video a lot. Just in this kind of era of reaching students remotely and trying to explain things. And I've been doing this new thing where I do these code walkthroughs are actually based on some learning theory that are supposed to kind of help people who are new at developing skills develop them better. So we'll see. We're not doing a research study on you guys, but thanks, Jason. Okay, so back to our topic. We're going to first just talk about packages. Again, I go through this stuff pretty slowly. I want to make sure everybody's on the same page. If I'm going too slow, let me know, or too fast. So I've zoomed into your RStudio window, and what we're looking at is that lower right-hand corner, okay? And I've clicked on a tab called Packages. Here, you can see a list of packages. The list of packages are hyperlinked, right? Extra font DB, foreign, ggplot. Okay. And then you see a description of what these packages are. If I clicked on any of these hyperlinks, I can get some documentation about what these packages actually, the meaning of them, besides like graphics, the R graphics package. You can see that's mildly descriptive. So you can click and learn more about the functions that exist within that package. If you remember, a package is a collection of functions that work on a particular set of objects. Some of those objects might be data frames or tibbles, or it might just be any data that's of type numeric, for instance, or character data. So I have a question for you. What does it mean when there's a check mark next to a package name? Thanks for the responses. So first, every package that you see here is installed, whether it has a check mark or not. Okay. Second, anytime there's a check mark next to it, this just means that it's active or enabled. Okay, so I heard Anne and other few people mention that as well. But there's two pieces to this. So the list of packages, whether there's a check mark or not, you have them installed. And if you look at yours, you might not have the same ones as I do. So that means that we have to go ahead and install packages. And we install packages by clicking the install package icon here. Pretty straightforward. And it asks us to kind of search what's called like a CRAN repository. Okay, CRAN. And we type in our package name. You might have already done this with the psych package. We know that package names are literal and spelled exactly as they are kind of created. So if I have something called GR capital D devices, that's how it needs to be spelled, okay? When you try to install it, it may try to correct you, but sometimes, you can be going really fast and it'll say, oh, hey, this isn't found. And that can be a frustrating experience. A lot of things in programming have to do with typos, okay? Most of the time we know what we're doing. It's that we, make a typo or some kind of error like that. And, in traditional programming, that's called like a compilation error, right? So before the code is run, we make the mistake, we decide to run our code, right? We write it at the console window, and then when we run it, it's pressing enter. Okay. So that will throw what's called throw an error. But that's really all I want to speak to you about packages. In addition, you may want to, you're going to be working in R for a variety of, for many classes in this program, and it's going to be important that you check for updates, okay? Because packages are created by the R community, and the R community actually has people in it. And so packages are created, it's easy to say, oh, the R community, but it's really, people. And so somebody created the ggplot package, for instance, or the grid package, and they tend to update that, and they will update it to the CRAN repository. And you'll be notified in this window if updates are needed, okay, when you press the updates. Pretty simple stuff. If I wanted to find out at the command line, not here, what packages I have installed, what would I type? Anybody know what the method would be? Great. Yeah, library. Yeah, with two parens, opening, closing parens. Okay, good. And if I wanted to literally, through code, not through checking the box, what would be the code that actually would check the box for GG themes? So then I could use it. So we want to use the library function again, but we just pass in the library we want to enable, okay? Does anybody know what the GG themes package does? Okay, it's a personal favorite of mine. What it does is it actually allows you to create, it allows you to format your data graphics, which are your charts and graphs, using particular themes. What's a theme? Well, there are different styles that are provided, and there's a style called, like, Tufte or economist. So Edward Tufte is known as the grandfather of data graphics. So you can make your charts look like Edward Tufte created them to some extent, or that they were published in The Economist, or that they look like they were created in Excel, or they look like that they were created in Google Charts. So it's pretty cool. We'll try when we get to graphics, we'll like try out using GG themes during the next online session, just to we'll do more of it, of course, in the data visualization course, but I'm kind of a believer of like making your stuff look good and not waiting until module 3 to do that. And this is a simple way to make your stuff look pretty decent. However, you're going to have to learn a little bit about that these themes can only be applied to ggplot2 objects. Okay, so that means anytime I create a graphic that's like a boring histogram that was created using the graphics package or some other package that's not ggplot, I can't apply the themes. Okay, so certain things only work with certain objects. So enough on that, which is something to look forward to. And here's just like the write-up of what packages are and what we discussed. Okay, so I like just having this here for those that are watching the recording. Second step, importing our data. This is the second thing I want to talk about today. So importing data, we can do this in a variety of ways. So if I had a CSV file, what are 3 ways I can import data? Molly, I'll return to your question. It's a good one. Okay, Rebecca gave 1 way, using the import button. Great. What's another way I can? Okay, read.csv. That's another way. And read_CSV. You guys are great. Yeah. Those are 3 ways. We are going to talk about specifically what the differences are between these 2 functions. But I'm going to ask you to respond first. Do you see any difference between these 2 functions? The read.csv versus read_CSV? Why would we use one over the other? That's really what I'm getting to in my question. And Kristen, why are you showing us a million ways to do things? Why? We should just learn one way. Format of the data file. I'm just waiting for a few more responses. Well, first, I want to make sure you know how to. That's a good answer. I just saw come up from Prasanji. I want to make sure that your knowledge of R is deep and extensible. And so if you learn one way to do it through pushing a button, that's not going to work really well if you want to write your own scripts and code that you have to run and execute. Not going to be able to do that if you need to press a button and intervene. So we write code in terms of programs or scripts that are run in a step-by-step linear fashion. And if we depend on a human to go ahead and press an import button to import the data halfway through the program, guess what? Our whole program's not going to work. So first, read.csv comes from a different library than read_CSV, okay? Chances are, and Molly, listen a little closely to this one, starts to answer your question, that the library utils is kind of pre-installed in R and it's always enabled, okay? the readr library might not always be enabled. So before I use the read_CSV function, I might have to enable the readr library. Okay. Second, using read.csv, the R object is imported as a data frame data structure. So those three words that I used before, R object, data frame, and data structure. Okay, those all go together here. So let's say I import a data file called, my data. Okay, my object is called my data, and it's of data type. It's of type data frame, and you can use that class function to verify. And the type is data.frame. Okay, to be specific. This function, read.csv, by default will import any data that you have that is of type character. So you import a data set, it's of type character, some vectors are of type character. It will coerce those to factor variables. It's a pretty nasty thing to do. That means that you have a variable called name of country, and not only does R import that data it imports that data not as a character, but and we know name of country is going to be unique, right? There's not two countries with the same name, at least that I know of. And assign a number value to it as well as a string value. Okay, so that's what happens when we use read.csv. Well, why are you telling us this? We should probably use the other one. I bet it's better. Yes, but read.csv is still actively used in the R community. You will find it in the documentation. You will find examples that you use read.csv, and I want you to know why. It's older. So last year when I taught this class to the MSBA group, read_CSV was relatively new. Okay, so just to give you a sense of how contemporary the packages are that we're using. Okay. Secondly, with read_CSV, the R object is imported as a tibble. So you might have heard that word before. I think it sounds kind of funny. A tibble, which is just a simple data frame. Okay, now I have an R object. It's a tibble, that's a data frame, that's a data structure. Okay, but just so you kind of get all these things together and how they relate. And this function was designed to remove characters as factors. And what I mean by that, it doesn't import or coerce your data. Okay, if you have something, a column in your data set, it's going to import it. If you have a column in your data set that is of type character, it will import it as of type character. Okay, and that's pretty handy. It also is generally, like from what I've read, it's faster. I haven't proven it, but just what I've read about that. Is there an easy way to know which libraries are enabled? We can type the library function, and that's how we can see which ones are enabled. Or we just go and we look. Okay. When we write our code, we will begin to develop a knowledge of what libraries might not be enabled for us, especially when anytime you have to import a new package, chances are it's not going to be enabled. Okay. When you import a new package from the dialog box that I showed before, here using this button, and then you want to use it, and if you didn't check the box here, chances are that box is not going to be checked for you. Yes, so you can import a package that's not enabled. Anything here are packages that you have access to. They are not, and let's not use the word import, we should use the word install, okay? Anything here in this list is installed. Anything with a check mark is enabled, which means that then I can access the functions used there. So are we clear the differences between read.csv and read_CSV? I mean, if I were you, I would want to get to coding pretty soon today. But I like to take the time to explain this. It's important for you to understand, especially as you look for the documentation. I hope that, I've heard it's faster, Pranjit. Yeah. Which one is equivalent to the button? So you can do both, but you can import from readr, or you can import from utils, and it gives you the option when you in the drop down for the button. Okay. Ciao, good question. So let's look about how we write this in our code. So anytime we use the read.csv function and we're writing it by hand, not using the button, we pass in our data in double quotes, right? Separated by a comma, and then we add 2 other parameters, usually. So CSV, .csv, does anybody know what that stands for as a file type? I know this one's a simple question, but just want to make sure everyone's clear. Yeah, comma separated values. Thank you. Yeah. So that means that doesn't mean that a .csv can't be tab separated. It's possible, but chances are that it's comma separated. We include the separator here. All the files you'll be working with that I gave you are comma separated. Most files tend to be comma separated that have a .csv extension. And header equals true. I think you remember this from last time. But header equals true means what? The file has a header. First row is header. Let's not use the word header. First line is the name of the columns. So, right, remember, like, we don't answer a question using, like, a definition using the same word. That's the name of the word that we're defining. I'm just joking with that. But so a header equals true means simply that the first row of our data contains the variable names, okay, for each of the vectors in our data set. So think about when you create an Excel file, right? It's organized into columns and rows. Your columns are labeled like A, B, C, D. Your rows are labeled 1, 2, 3, 4, and so on. But then you add column names below the A, B, C, D, E, F. And that's what I'm talking about there. All right. Let's keep going. When we're using the read underscore CSV function, first, we typically, which is not written here, we enable the readr library. That's going to be a practice that I want you to do. Second is that we are going to assign it to a variable data, and we're going to just pass in our Winter Olympics underscore CSV file here. Read underscore CSV is pretty efficient. If I'm importing a CSV file, it doesn't require me to explicitly say separator is a comma and header equals true. Those are defaults, so I don't even have to write it. It's great. So you should never really forget how to import data. In the past, teaching this, for some reason, this is just a kind of difficult to remember how to import data by hand. I think it's because of these different parameters. But with read underscore CSV, it's one line of code plus requiring the library. So not too bad. What is implied by these 2 statements, read.csv and read underscore CSV? I'm referencing a file called Winter Olympics. What's implied about where that file lives? Yeah, it's stored in a working directory or working folder. So that means wherever my code is, if I'm writing an R script, it should be stored in the same place that my data is stored, okay? Otherwise, I have to change what's called the path of where my data lives. So that means that we also have to make sure that we always have our working directory set to the right place, okay? How do we set our working directory? Does anybody remember? There's two ways. There's a way that we can use buttons in RStudio, or we can use a function. And you can clearly see in the text chat, a few people mention the function. Excellent. Set WD. And Brock, thank you. You're giving us the graphical way. So you go to the session menu, you say set working directory, and then you navigate to a folder that's going to be your working directory. So we're going to go through this to make sure that we're all set with that. I'm going to show you both ways. All right, any questions? I saw the question about the pipe. To be honest, I would probably look the R documentation for how to do that. What the best function would be to read that. We're not, there are different functions to read different file types. Okay, so if it was a pipe separated file, that would be my delimiter, I think. Okay, that would be the only thing that would change. But if there's some other attribute of that file, I would research the documentation. But if it's just delimited by pipes, then I could add that as a delimiter instead of comma. Paulo, good question. So do we always need to move the files for import into the working directory? No, you can make sure that you reference where they're located here. They could be on a website, okay? But if you just want to say, read.csv and just type in literally the name of the file, that's the assumption there, it's in your working directory. Does that make sense? Otherwise, I have to say something like, that's saying go up a directory, go to my desktop, and then find file.csv. But you might have some directory path. I do everything on Dropbox. That's just you'll see when I'm in the code, because I switch computers a lot. So my code always works because I reference Dropbox. So I never have to be local. Or tilde, right. Thanks, Anne. Awesome. All right. Stanley, I don't quite understand your question, so maybe you could rephrase it or send me a note with the website so I can clearly answer that. They're not the same, Anne. Let me answer that one later as well. Okay. So a few things on R scripts. First, there's many advantages to writing a program ahead of time before you execute it. So we've been doing a lot of things. We've been working at the command prompt, and we'd say something like, round a number, okay, and then we get some kind of output, right? That would look like this. Okay, so just as a silly example, that's like the idea of input and output. Problem is that, let's say I made a mistake, I passed in the wrong data, etc. I have to actually re-enter all the code again and rerun it. Very easy to, just like when you write papers or anything, you can save it. Same thing with R. And so we're going to create R programs, and they're known as R scripts. They have a .r, capital R extension. This also allows for reusability. So not only for allowing you some time and space to think through what you're trying to achieve with your code, and problem solving, for example, you are able to reuse your code. So if you forget, you might do 6 standard things every time you import data, and I have you do it. So you should probably know what those things are, but you're probably getting bored of doing it. But I'll say okay, set your working directory. import your data, take a look at your data, tell me what the names of the columns are, tell me what the dimensions are, how many columns and rows exist. Those types of things you might want to, kind of cut and paste every time and reuse those and not write them, and just, all you're doing is changing the R object that you're referencing, the data object. It also allows you to document your work. We've been using the pound sign to put it like inline comments in, which is great. You can also do that, of course, as part of your R script. It also allows you to share your work with others. So not only can you share your work by kind of literally emailing your .r script to people, but you can publish it. So R is pretty amazing in that you can publish your work and format it for a variety of uses. So you can publish your work as like a PowerPoint presentation, or as a blog post, or as an HTML document, or as a Word document, or as a PDF. So this package called knitr is very cool. It lets us do those things, okay? And we can do a lot of nice formatting there. And then it allows us to kind of progress in our coding. We can move beyond writing one line of code at a time. So creating an R script, this is just a text way of telling you how to do it. I'll do a demo, of course. We're going to go to the file menu and say file, new R script. Brings up a blank document. You'll notice immediately the number 1, which references the line number. And then you can simply start writing code. It's not going to be executed until you kind of highlight and then press the run button. Okay. There's a few other ways that we can run it as well, which I'll show you in the demo. So now let's get to work on exercise 3. I'm going to start by doing a few demos of setting our working directory and importing our data and creating an R script. So I'm just going to switch my screen to R. And you notice that I have, a bunch of stuff up as usual. So I always like to kind of show you how I'm working. No, I like to show you kind of where I start usually, and then I go and clear my console. And now I'm going to go and create a new file, new R script. Okay, that's all I did. I said file, new file, R script. Nothing saved yet. Okay, and I'm not going to save it for a minute. I'm going to use the pound sign. I'm going to write my name on it. Maybe you can write the date. I think it's the 6th. Let's check that. Somebody can tell me what the date is. Yeah, it's a 6. Okay, 2018. Okay, so comments, are just documentation about your work. The next thing that I'm going to do is I'm going to set my working directory. And we heard how to do that using the set working directory function, right? But on line 3, I'm not going to do that yet. I'm going to show you the graphical way to do it. So we're going to go to Session, Set Working Directory, and then we're going to choose Directory. So I'll keep that up for a moment. So now you see that it's bringing me to a folder called R Fundamentals. Actually, that is my working directory, so I'm just going to keep it and just say Open. Notice that in the console window, it actually prints this. So when I use the tilde here, it's taking me back to my home directory on my computer, okay, and then it's going to my Dropbox /R Fundamentals. I really like putting all my files on Dropbox because, again, I can use different computers to do that. Diego, that's a good question. I never tried it with Drive. I'm not a big Drive fan, but I mean, I use it all the time. Yeah, because NYU email is Drive, right? I'm sure you can. If you have it mounted, you probably have a directory path. If you have if you have it mounted as a disk. So I'm going to go ahead and, yes, David, there is. So I'm going to go ahead and copy this code and put it in my R script. And then I'm going to write a comment that says set working directory. Why do I do this? I mean, going through this very slowly. The reason why is because when you come back and look at this code in a week or 2 weeks, you may forget where your files are stored that are referenced in this particular piece of code. Okay, so I want to just make sure that that's set and it's clear. Okay, we haven't talked about how to create projects or anything in R yet, but projects are a way to kind of keep your working directory persistent. Okay. So David, you said thought you were only doing it in the console. No, so I just showed you the way to do it using a graphical way, and that's a way to get your working directory, so you don't have to figure out what the path is. Okay, cut and paste that. We're not going to do both every time. So in our R script that we're planning ahead, we've set our working directory. The next thing I want to say is we want to save our file. So file, save as. The nice thing here, it's going to save it in our working directory again because we've set it. Okay, so I'm going to save this as exercise 03 demo demonstration. Okay, I have a few of these floating around. And then we'll say save. And you don't give it a .r extension. That will come automatically. And you notice that I have something called up here, exercise 3 _ demonstration.r. Okay, there we go. Next thing is we're going to import our data. So just like we said, our working directory, I'm going to show you the 2 ways we're going to do it. And in this example, we're using the March Madness CSV file. So we're going to say to import it, just got to move my screen around a little bit so you can see. We're going to say import dataset. And I can say from text base. That will give me the read.csv function. We know that we want to use the readr, okay, from what we've learned about from the advantages of it. If you had data of other sorts, you could pick these. So let's choose the second option from text readr. Good. So now I'm going to browse, and guess where the browse button is going to take me? Directly to my working directory. And then I have to find my March Madness.csv file. I'm going to go ahead and open that up. And I'm going to look at my data in the data preview. Everything looks pretty good. I love how it's bringing in schools as characters and conference as characters right now. And I'm going to rename here my data frame. That's going to be of type Tibble, just March, because March Madness is really long. So this is where you can change the name of the data frame, and everything else is going to be default. First row is name, delimiter is going to be a comma. Okay, if I had a pipe, I would choose other here. Okay, and everything else looks good. And you notice that we even get a code preview. And so that's the thing that I want to emphasize. We say import. Now our data has been imported. A few things just happened. When we use the graphical way of importing data, it imports our data and it launches this view function. It says view March, and then we get something that looks like a spreadsheet. We don't ever use the view function in our R scripts. Okay, our view function we just use at command line in RStudio. It's like one of the specific functions only available to RStudio that launches this nice graphical view of data. That's all I want you to understand about the view function. We don't ever use it when we're writing our scripts. So why don't we scroll up a little bit and go ahead and copy from the console window library readr and how it read in your data using the read.csv function. We're going to copy that and we're going to put that in our code here. Again, we're not doing this every time. I'm just showing you the differences between the two. So when we plan our program, we're always writing it out. And then we're going to make a comment and we're going to say importing our data. Okay. Let me know if there's questions at this point. So at this point, now we can begin, writing some other code, which again, following along with the exercise is like viewing our data. So again, we're not going to use the view function here. We're just going to write March. And let's say I just wanted to view our data. Got to scroll down a little bit. I want to run line 12 because we know we set our working directory already. We know we've read in our data. So I just want to run line 12 and I'm going to say run. Then I'll see my output, which is, a preview, a data preview. Okay. The next thing that we want to do is we want to print the number of rows and columns. So how would I do that? You could paste your code in the text chat. Good, we can use the dim function. So dim March. Has this been run yet? No, line 15 hasn't been run. I just planned that out. Okay, I just wrote it, but it hasn't been executed. So now line 15, I can put my cursor at the end of that line and press the run button, and now that code will be run. Okay? And I see that I have 349 rows and 9 columns. So let's print the column names. So how do I print the column names? What function can I do use there? I could use the names function. Good. So printing the column names pass in my data structure, my tibble, which is March. Okay. And then I can run that and I see the output of names. Gosh, this is annoying, right? Names are all in uppercase. So what I'd like you to do is change those names to lowercase. So send me the code via text chat, how you do that. I want you to update your data frame of type tibble. So all the columns are lowercase. I need the full code, Benson. So that's one of the that's a function we're going to use, but it's not the only one. That's good. So once you have the full code for how I update the column names, just cut and paste it in the text chat. Let's see, maybe somebody just joined a little late. Welcome. So I might see a typo, Jason. Looking good. Those who have posted. Okay, so let me walk you through it. The answer's in the text chat, but we're going to use a function called toLower, right? And what do we want to make lowercase? Well, we want to make the column names lowercase. And we know that this is how we found the column names before, by using the names function. So a function within a function. No problem, Nee. Then we're going to simply assign that back to names March. Okay. Now at this point, nothing's been run. Change my column names to lowercase. And line 20, when I run that line, I can highlight the whole line too. It's another way to run it, and press run. How do I know that they've been updated? Well, gotta use names March. Gotta write it again, right? Because we're going sequentially here. And we could say names March. Everything is lowercase. Wonderful. Nice work. All right, the next question, we're on number 7 already, explore the variable types. And so here, I'm mentioning that you should use the str function, the structure function to explore the variable types so you can learn a little bit more about your data. So explore variable types. And again, that's just using str, passing in your data frame. Okay. You'll be able to look at your output a little clearer than I can. And I have to bring this page all the way up. And here I can see that a few things when I use the str function. Okay, so TBL underscore DF is our that means that we have a data frame of type Tibble, okay? It shows that we have 349 observations of 9 variables. It lists those variables all in lowercase. Very cool, right? And what the data type is of those variables, and what are some of the values that are for each of the variables as well. Okay, so just gives you a little bit of a preview. So now let's get to some content questions. Okay, so exploring our data, that was question 7. I'm just going to go back and rename these, change my column names. I believe that was question 6. And I want you, as I'm kind of formatting my code, I want you to answer question 8. How many different conferences are there? And when you have the answer, please type your answer in the text chat. I'm going to give you like a minute to do this. I'm going to fix my code, maybe get a cup of coffee, wait for you to finish that question. If you are fast and have done that, move on to question 9. Tell me the difference of values between the two columns. And then print a list and count of schools that have changed 3 or more places. So start with question 8. So Matt, you got the answer, but I need the code. You have to prove it to me. You might just be a basketball fan. Yeah, that's a good way. There's a couple ways to do it, so I'm going to wait for folks to share. Right, Rebecca, so you're putting that line first before you do the length of the levels. Okay, I'd like to go over the first one, which is number 8. How many different conferences are there? So somebody just told me 33. So how do we get to that number 33? We know that there's 33 different conferences. Okay, so there's a few approaches. Actually, there's 3 that are really good approaches to doing this. So let's go through one that's a little slower. So I'm going to say approach 1. I'll show you all 3, okay, as a demo. And I'm just going to move down my console window a little bit here. Here we go. Okay, so 1 is that I can cast my conference variable. So if you remember, just bringing this up here, conference, this is a variable of type integer. I'm sorry, of type character, excuse me. And I want to change this variable to type factor because I want to associate a number and a string with a particular data element in this vector, okay? And a lot of people have done that. So Jason has an example of that. Awesome, and many others. So to do that, let's do it slowly. So first thing I want to do is show how to cast that variable. So I use a function called asFactor. Okay, and then I'm going to pass in my data column, March $conference. And then just reassign that to the same variable, March $conference. So now I'm manipulating my data frame, right? I'm actually changing that column to a different data type. That's all that's happening here. So I'll call this approach 1. So I can get a number, and a unique number will be given to each conference that's unique. So that's what's going to happen here. Let me show you what I mean. Western Athletic, for instance, will have all these observations will have the same number associated with them. Let's pretend it's 1. West Coast will all have the same number associated with this, which let's just say is number 2, okay? And then from there, we will be able to look at what's called the different levels that exist for our factor variable. How many levels are there? Well, we're going to hope that there's 33 because we know that that's the answer. How many unique conferences? Okay, it's the same thing. So let's run line 22. And you probably can't see that in my R script. So, okay, so I think I just ran that. Don't look at what's happening in the console, I'm just erasing it. Okay, so let me check my work by just on line 23, looking at my data. And it just gives me all my 349 observations here, but it says 33 levels. And that's giving me my answer. So that's one way I can get that answer. But if you're not going to want to look at all this data, and I just want the number 33. How do I just get the number 33? So we could do a few things. We could say length, levels. I'm writing exactly what Jason has here. March, conference. I could run this. Make sure I have no typos. 33. There's another way. It saves me a tiny bit of typing. It's called n levels. Guess what that means? Number of levels. And then I can pass in March conference. Okay. 33. Again, telling you guys that there's just, you know that there's a few different approaches to solve problems in coding. Let's look at approach number 2, okay?
even though even in approach number one, there's a few ways to get the outcome that we're looking for, okay? And then, I mean, going back on line 25 or 24, then you could store this in a variable, right? And then you can have that number 33 accessible if you wanted to. And what I mean by that is I can store that in like a variable X, right? If I wanted to. Use that for later. Okay, approach number two. Approach number two is I can use a function called unique. I don't know if anybody's used this function before. I haven't introduced it to you. March $conference. So if I do this approach and I run it, it's pretty much giving me the same thing as levels. Okay, but so then I have to take the length of that. So it doesn't really save you any time using this, but that's just another approach, okay? So let's say you're not dealing with a factor, and so length is always great. Unique is a great function to show you the unique conferences that, in this case, that exist. Okay, so those are the two levels. I said two ways. I said there's three ways, but actually in approach one, I was kind of showing the two different ways of approach one. So it's like approach 1A, approach 1B, and approach 2. Questions on this one? So I'm going to take a quick pause just to show you something, because I know that we're going to go up to the very end. And one thing that I think might be helpful to you is if I just show you how you can kind of publish your work and share it with others. And the reason why I want to show you this is because I want to give you the code that I'm working on today, give you the URL for that, so then you can follow along if you want later. So I don't know if that would be helpful. I've heard from some students that would be helpful in the other online sessions. So I just want to pause before we solve question number 9 to show you that, okay? So if I wanted to publish this R script, say on the web, and then I could share it with you instead of emailing it to everybody, and then anytime I wanted to update it, I could just update it, and then your link would be persistent. I have this little notebook icon here in RStudio, and it says compile a report. Now, in order for this to work, all your code needs to work. If your code doesn't work, you're not going to get a report. Okay, so everything needs to work here. I should be able to highlight this and run this code all at once and it to work. So I just literally did that. I highlighted lines 1 through 29 and ran my code. I got no errors, right? I don't see any errors in the console window. If I, let me make a typo on line 25. I'm going to highlight all my code and press run. I got an error along the way. You see that? Object mark not found. Okay, so let's fix that. And I've already kind of proved to you that my code is working. Then we're going to press the notebook icon. And then we can compile a report from our script. Okay, and we can choose our formatting output option here, HTML, PDF, or Microsoft Word. So that's pretty cool. We say compile. Again, that means that our code needs to be run and active. And now this launches a preview window. And it does a few things. It gives my username that I'm using, the name of the file, the date, and then all the information that that I've typed in my code, in addition to the output. So here now you're seeing input and output. So here's my input, dim March, and here's my output. And it does the output as the double pound sign, okay? Just to show you. So you'll even see the output of everything here. When we get to our markdown files, we can even control what we show in this format as output, which is pretty cool too. Now, at this point, you can open this in a web browser, see kind of what that looks like in a web browser. Nothing doesn't really look any different, but I'm going to go back to R.
and I'm going to use this publish button. If I say publish, I can publish to RPubs, which is a free service for sharing any kind of documents on the web, our studio documents. I choose that, and I say publish. And I mean, don't go here to find like my master R code, because I use this as a place to, I'm sorry, I was talking, and let's go back here. So I'm going to go ahead and republish, update existing. You need to have a username and a password for this. So I have a username and password for RPubs. Otherwise, you sign up for an account. And then it gives me what's called a slug, which is my URL. And then I'm going to call this exercise 3 demonstration. And then I'll say 4.6 or something. Good. And then I say, and then this tells me kind of my directory. And if I wanted to name it something, I could say I can name it something, but I'm not going to name it. I'm going to wait for RPubs to give me a name for my file. I'm going to say 2018. Continue. Now it's published on RPubs. I can go here and I can do that. I use GitHub as well. I like the integration of this. Really, it's really nice. And I use RPubs as an intermediary. I like using my own website, actually. But you should definitely use what's the platform for publishing your code that you like the best. So I just gave you access to this document that we were working on together, just so you have it. Okay, and then I'll update it at the end, and then you're with the additional solutions. Okay, well, I hope that was helpful to kind of show you how you can go ahead and publish. Again, I just pressed this button here, compile a report. Okay, the assumption here is that your code works. Okay, so next we're going to go to question number 9. But let me pause. Are there questions on any things I just went over? All right. So how would I solve this problem? So let's look at 9a. Compute a new vector called difference and calculate the difference in rank from previous. I saw some good solutions here. Excellent. So we want to do simple subtraction here. We want to subtract March rank from March previous. Okay, that will give us the difference in rank. And then we want to create a column called difference. And we simply create a column by saying March diff. I'm not going to execute this code yet. Let's look at our data. So right now we know we have 9 variables and 349 observations. Okay, what I want to do is I want to add another column here. To add another column, it's just using the name of your table data frame and $, another name that doesn't exist in the data frame itself. Okay, so I'm using diff. We know that doesn't exist as a variable. And then I'm storing the result of the computation in that vector. So many of you have done that. Okay, and then how do I check that out? Well, here's the shortcut. I'll just since we're writing kind of in time, you see that I have a new column here called difference. DIFF, okay? Good. I could also, of course, type out, March and run that. And then I'll see that I have a new column created. Wonderful. Now let's do 9B. I heard there's maybe some questions on the exercise 4. So we want to print a count and list of schools that have changed 3 or more places. Let's do that. And if you already pasted in the text chat, just do it again for me as a favor, because it's like Twitter. I can only see the last couple without doing more work. But I am scrolling up just to kind of see what people have done. All right, good, good, good. I don't think anybody's answered this question in the text chat. Print a count and list of schools that have changed 3 or more places. And I'm saying, there's a hint here to use the subset function. Okay, take a subset, and that's going to give us our count if we want to get that reference, right? Because we can take the length of that subset, and that will tell us the number of observations. Good. So seeing a few correct solutions here. So let's go over the what I want to do. So I'll call this March, subset. That's going to be my new data structure that I'm storing the result of subset function. Okay, so I want to subset my data. What data do I want to subset? And that's where I pass in X. X is, this is just being literal, the name of the data object. And then we say subset. And then a lot of you have this right. This is great. We're going to say difference greater than or equal to 3. I'm going to pause here for a second. Now, difference greater than or equal to 3, this is my condition. So that means that I want to be stored in March underscore subset a portion of the March Madness data based on this condition that difference, that new column I created, DIFF, is greater than or equal to 3. Again, let me take a moment to explain. Let's go back and just look at our data. Always good to look at your data. Greater than or equal to 3. So if I was evaluating this as using that function, this would be false, this would be false, this greater than or equal to 3, no, false, 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 going down, right? At any time it's true, where I see a number 3, a positive 3, it's going to add that to my subset. Good question, Jason. So let me keep walking you through. Because I'm looking at my statement saying subset equals difference greater than or equal to 3. Greater than or equal to 3. Positive 3, not negative 3. That's what my condition's saying right now. Okay, if I do that, and I show you what's there, I'm going to see, my 3 observations that have changed 3 or more places. All right. But the mistake there, as many of you have caught on to, is that I'm only looking at the positive difference of 3 places. That a team has changed in a positive way. They've gone up in rank, or lower in rank, I guess, right? Well, the higher the rank, the better. So rank 1 is better, but numerically it's lower. Greater than or equal to 3 places. Okay, so I could
do two conditions. I could say subset equals difference greater than or equal to 3 or less, or greater than or equal to -3, something like that. All right. Or I can take the absolute value, okay, of my difference variable, like so. So it doesn't matter if I'm looking at the absolute value of any team that's changed 3 or more places. So now I don't have to worry about those negatives because I'm taking the absolute value, and now I can just have this one condition. Does that make sense? And then I can run this, and when I run this, and I go ahead and I say, I just want to show you the data graphically, March subset, wow, now I have 9 instead of 3, okay? And you can even see the difference column. So with the previous one where I wasn't using the absolute value, this row 1, row 2, row 3, row 5, row 6, 7 were omitted. Alrighty, so that's our exercise 3 demonstration, exercise 3.1 demonstration. I'm going to go ahead and save that, and I'm going to compile my notebook and resend you the URL, even though you have it, but just so you have it, text chat right now if you didn't catch it last time. And it seems like, people, all I know is the people that are participating, that you're getting it, you're doing well. For those that aren't participating, I don't have any insight into that. So just ask you, like, to if you can, to participate. Just gives me a cue that you're getting it, or that this is, I should go faster or something like that. Otherwise, I will keep at the same pace for future sessions. Now, if you want, I can begin going over exercise 4.1, and I know you had a question. Did you want to raise your question, or did you want me to start going over exercise 4.1? You have 2 questions. Okay, if you can ask them verbally.
Oh, hi. This is faster. So I was wondering, when we're doing all of the measures for, mean, sum, whatever, can we do multiple variables at the same time in 4.2? So can we take the mean of a list of variables, or do we have to do them one by one?
Oh, okay. So good. Let me mute everybody for now. Part of that exercise is just getting comfortable with those functions. I mean, you're generally not going to do it the slow way, okay? But I would just suggest doing it the slow way and then checking it with the summary or describe function. That's really the point of that. But it's not like a real life situation. It's more just getting practice using the functions and having expected outputs.
Oh, okay, that's fine. And my other question was, what was the function attach?
Oh, okay, attach function. You know what's cool about the attach function? You should come to a demo. Okay, so let's say, I'm going to go in my code here, line 30. Say if I say attach March subset. And then I can, once I do this, I can reference the variables without saying March subset $, diff. Okay, I can just use plain old diff. So, or what's another variable that I have in there? School. Okay, I can just say school. Let's do one more. Okay, and then let's just do something like, which we'd never do, sum rank, right? If you want to do some kind of function. Okay, so if we run this, just to kind of prove my point, attach March subset, diff, it prints out diff, right? School, and my sum. Yeah, so it's an easy way not to have to say, data frame, $, and then the vector name. You want to make sure you use the detach function afterwards.
because you might have variables that are the same name in different data sets and blah, blah, blah. Don't want to have any problems. So always have a detach after. Okay. Any other questions? We're at about 9:27. So I'll just mute yourself, but I've given everybody microphone access. So if you have a question, you can use the mic. Or you can simply use the text chat. Alrighty, so I'll stick around for a few more minutes. But if you don't have any more questions, I'd encourage you on your own for just practice, do exercise 4.1. Obviously, you know, for the required exercise is just exercise 1.1.2, 2.2, 3.2, 4.2, 5.2, and 6.2. Any ones that have a .1 after them are practice. Okay. The next session we will be going through 5.1 and try to go over 6.1 if we can, if we have time. Thank you, and please let me know if you have questions. And I'll send around an email a little later with the recording if you desire to rewatch this session. But you have the URL of the RPubs. I just pasted it in again. You're welcome. You're welcome.
Thank you. Have a great day.
You too. You too. Thanks.
Thank you, Kristen. Thank you, guys. Have a good day. Bye-bye.
Okay, bye. Thanks. Benson, I did. I have to check that out. I'm sure that was my blunder. So I don't know if you're still online, but if you have your mic, we could just talk about it. I have to take a look at that. I think that I probably didn't upload the right images because when I generate the code, I might have updated the images, not uploaded them. Is it disruptive for you? I can try to fix it now. And I'm waiting for Benson. I'm looking at Stanley's dataset media nodes, blah, 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 header T. I don't know what this HTTP as equals T. That looks really odd. I'm not sure what. It seems like as is equals true, right? That's what that parameter is saying. So here's my instinct of how I try to solve that or understand that. Thanks, Benson. I'll look into it shortly. So working through Stanley's question about as is. Okay, so I would question mark because you're using read.csv too. So this is where I start, and then I look at the documentation and to interpret what read is means.
Yeah, I see it there now. String as factors.
So yours says as is HTTP. Do you see how you pasted it in? I'm kind of confused by that. Strings as factors. That's this. So this, good. I'm going to repaste it though, because yours is pasted. Do you see how yours is pasted, Stanley? It says HTTP : gives you it looks like a URL. So this, it did it with mine too. That's so
Yeah.
Okay, that's why I was totally confused what you're talking about. Okay, so glad we looked at it this way. As is means that it's going to, by default, this is set to true with a read.csv file. This is an annoying thing about this unless you explicitly say false. Because anytime you have a string like name of country or conference or anything, it's going to turn it into a factor. Sometimes we want it to, but usually we don't want it to happen for all of our strings by default upon reading in our data. We'd rather convert it or cast it later. Make sense?
Yeah.
But that's why we use read_CSV. It does not coerce our data. It does not put it in as string as factors.
Yeah, got it.
Got it? Okay, cool.
Thank you, Kristen.
Take care. Okay, it looks like almost everybody's gone, so I'm going to take off. Thank you. And I'm going to go ahead and stop the recording. Further questions, please feel free to email, and then I'll see you next time. Thanks a lot.